Okay, let's start today's session with something called as chi-square test or chi-square test. So here is the problem we go. Use the chi-square test with alpha equal to 0.05 to test whether the data shown are uniformly distributed. The test uses n equal to 10 of equal interval, and these are the 50 numbers given for you. Okay, 0.34, 0.90, 0.25, 0.89, 0.87, 0.44, 0.12, 0.21, 0.46, 0.67, like that it goes on. So just check the data. So now let's see how we can solve this particular problem using chi-square test. Okay, so first what we have to do is, you can see here that it's given as alpha equal to 0.05, that is the level of significance value, and n equal to 10 of equal interval, means these 50 values you have to divide it so that we can get the classes as 10. So what we can do is, the maximum probability value is always 1 and the lowest probability value is always a 0. So let's divide the intervals of n equal to 10. So I'll start here. The range I'm going to divide. So this brackets already it's inclusive of 0, sorry, excluding 0, including 0.1, then again 0.1 to 0.2, 0.2 to 0.3, 0.3 to 0.4, 0.4 to 0.5, 0.5 to 0.6, 0.6 to 0.7, 0.7 to 0.8, 0.8 to 0.9, 0.9 to 1.0. So we got the range 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That means I got 10 classes. I divided these numbers into 10 classes. So I can write that interval range here. This is my interval. The first, second, third, fourth, fifth, sixth, 7th, 8th, 9th and 10th. So small n value what is been specified here, n equal to 10 classes. I divided 10 classes. Okay, now next is nothing but we call something as OI. OI is the observed values. Okay, OI is the observed values. So now from this range from 0 to 0.1, here we have given many numbers here, right? So now I have to write how many numbers falls under this category. So here I have to exclude 0, it include 0.1. So if I consider 0.1 here, then I cannot consider it here. So that's what the bracket signifies. This is a normal bracket, this is a square bracket. Okay, so now under this category 0 to 0.1, when I scan these numbers, when I scan these particular numbers, there are 50 numbers given for me. I check how many numbers fall under these categories. If I check that, then I'll get some value called as 3 here. That means out of all those numbers, there are 3 numbers which will fall under this category. That is 0 to 0.1. I can scan, if you can see here, what are the numbers which will fall under that category. So I'll get the value as 3. Similarly, if I scan for this particular thing, what are the numbers lying between 0.1 to 0.2 range? When I scan these things, I'll get it as 4. Similarly, it goes on. Under this range, we'll be having 6. This range 4. Under this range, again it is 6. And this range 2, 4, 9, 7 and 5. So sometimes in the exam they will directly give you the observed values. In that case it will be easy for us to solve the problem. And if they doesn't give you the observed values, then through these numbers you have to scan where it falls and you have to write that particular values here. Okay, hope it is clear. Now let's go for EI. So what is EI? So EI, I'll write downside. EI is nothing but capital N divided by small n. Okay, so when in a capital N, then a value which is given for me. So there are 50 values given. So capital N value is 50. And what is small n value? It's already given in the question. N equal to 10 class. So it is 10. 50 by 10, I get it as 5. Okay, so all my EI values will be 5. So I'll write it 5, 5, 5, 5, 5, 5, 5, 5 and 5. Now I have a formula for chi-square. So before that I should know some notations, like what are the things required. So the other thing required is OI minus EI. Okay, OI minus EI. So let me do this. 5 minus 3, I get minus 5 minus 3 is nothing but 2. Sorry, 3 minus 5 is OI minus EI, right? So 3 minus 5 is minus 2. 4 minus 5 is minus 1. 6 minus 5 1. 4 minus 5 minus 1. 6 minus 5 1. 2 minus 5 minus 3. 4 minus 5 minus 1. 9 minus 5 4. 7 minus 5 2. 5 minus 5 0. So So I got my OI minus EI. Now next I require is OI minus EI whole square. So already I calculated OI minus EI. Its square is required. So it will be 4, 1, 1, 1, 1, 3 square 9, 1, 16, 4 and 0. So clear, right? Once I find EI, OI minus EI, then OI minus EI whole square. Now this is the main formula here, xi naught square. To find xi naught square, the formula is OI minus EI whole square. OI minus EI whole square, this particular column, that has to be divided by EI. Okay, OI minus EI whole square, this column has to be divided by this column, EI. So OI minus EI whole square divided by EI, that is 4 by 5. 4 by 5 is how much? 0.8. Similarly, 1 divided by 5, 0.2. Okay, like that it goes on. Next again 1 by 5, it is 0.2. 0.2. Then it is again 1 by 5, 0.2, 1 by 5, 0.2, 9 by 5, we get it as 9 by 5, 1.8, 6, 1 by 5, again 0.2, 0.2, 16 by 5 is 3.2, 4 by 5 it is 0.8, 0 by 5 it is 0 itself. Okay, so this thing now I have to add together. Okay, that what I get, it's called as xi naught square, that is OI minus E naught also xi naught square. Now when I add this, like let's see, 0.8, 0.2, 1.0, 1.2, 1.4, 1.6, 1.6, 2.6, 3.4, 3.6, 6.8 and 0.8 is 7.6. This is my chi-square value. Okay, whatever chi-square value I got is xi naught square equals 7.6. Now I have to compare with the table value as I did for Kolmogorov-Smirnov test, right? As I did for Kolmogorov-Smirnov test. So let us see here. They have given alpha equal to 0.05. So I have to find my xi square of alpha comma small n minus 1. In my Kolmogorov-Smirnov table I had capital N, but it is small n minus 1. A small n value is, as you already know, it is 10. So 10 minus 1 will be 9. So level of significance is given as 0.05 comma 9, because this small n value is 10. So 10 minus 1 it is 9. So this value is similarly I'll get from my table, appendix table, chi-square table. It's nothing but 16.9. Okay, 16.9. This is from appendix table value. Now let's just see my value, that is my xi naught square. Is it less than xi square of alpha comma n minus 1? That is, my value is 7.6. Is it less than 16.9? Obviously it is yes. So I write my conclusion. Null hypothesis that the numbers are uniformly distributed is not rejected. Clear? So let me explain you once again. First step is scan the numbers, write the range, because it is told as n equal to 10 range. So divide this entire number to 10 ranges. So 0 to 0.1 will get up to 1. So see the interval, 10 intervals are there as it is been specified as n equal to 10. Then see observed frequencies OI. OI means under this range how many numbers false, under this range how many number false. EI as I told you, capital N by small n, that is 50 number values are there, divided by small n value is 10 classes, so 50 by 10 it is 5, remains same. So OI minus EI, subtract OI EI, so 3 minus 5 minus 2, 4 minus 5 minus 1, let it goes on. Then OI minus EI whole square, this value has to be squared. Then your xi naught square is nothing but OI minus EI whole square divided by EI, this column divided by this column. So what answer you get at the last, that is your answer, 7.6. Now that has to be checked to the table value. They have given level of significance is 0.05 and here it is small n minus 1. So 10 minus 1 is 9, that is 16.9. So obviously your value is less than the table value. So the null hypothesis that the numbers are uniformly distributed is not rejected.